Today's lesson is the final section of our section 1-3 on measuring and constructing angles. It's part 3 of that lesson. And today we're going to focus on measuring and constructing angles and angle bisectors. That's going to be a new term for us. All right, let's do a little recall here on the angle addition postulate. Remember, if you have a point that lies anywhere inside here, so if this says if point B lies in the interior, anywhere inside the big angle, then the little angle AOB, right, that little angle there, plus angle BOC, this little angle here, those two angles will add together, whatever their measurements are, and they will equal the entire big angle. They will equal all of this measurement together. Okay? So again, that's our little angle plus little angle equals big angle. And remember, our little m right here you see in our angle addition postulate, that stands for m. And anytime you see a little m in front of us, an angle symbol, that's going to stand for measure. Okay, that's always going to stand for measure. All right, there's a couple extensions to the angle addition postulate, one of which is that it says if angle AOC is a straight angle. This time, instead of our angle AOC right here being either obtuse or acute, this angle here is straight, right? We still actually have 3 angles in the picture, right? You have angle AOB. Okay, I got to put a B on here, but that would be angle AOB, right? That would be all of this angle here, plus angle BOC, right, which would be this angle here. Those two angles add together would equal the entire straight angle of 180 degrees. So you can see here, this is a little extension of this. Little angle plus little angle equals 180, and that is when you have a straight angle. So whenever you have a straight angle there, your two little angles add together to equal the entire straight line of 180 degrees. Now, in this case here, you see it as a right angle. This time, angle AOC is a right angle. So our large angle is a right angle. We know it's a right angle, right? Because it has a box in it and because it told us it was a right angle. In that case, our angle AOB, right, which is this one here, that measurement, plus the measurement of this angle BOC here, right, that's this part, that's going to add together to equal 90 degrees. So again, we're talking about this little angle inside of here plus this little angle over here. Now be very careful with this. A lot of people tend to make the mistake and automatically tell me these are both 45 degrees. They do not have to be. This could be 60 and this could be 30. That could be 70, that could be 20. This could be 50, that could be 40, right? It doesn't have to be 45 and 45. This is not going directly through the center. Okay, if it was, that's what we would call as an angle bisector. All right, something that cuts the angle in half, but we don't know that this is being cut in half. Okay, so those are just two angles that add to 90 degrees. All right, let's take a look at these two examples. It says here in the directions to find the value of x. Well, in here you can see you have angle ABC, which is our 7x, plus angle CBD right here, which is 2x. All those together, right, this whole entire thing is a straight line right here. That's our straight angle. So we are going to set up our angle addition postulate to say the measure of angle ABC plus the measure of angle CBD is equal to 180 there, because that's the whole angle. We have a straight line here. So let's plug in our measurements. 7x is ABC plus CBD is 2x, and that equals 180. So 7 and 2 is 9x's equals 180. Divide by 9 on both sides, and of course x works out to be 20. Now, directions only said to find x, so just remember that's all you need to do. If the directions said something else, like let's say it said find the measure of angle ABC. Well, if it said find the measure of angle ABC, you'd have to take this 20 and plug it in. So again, if these were the directions, find the measure of angle ABC, you know that the measure of angle ABC here is equal to 7x, so you would take the 20 and you would put it in for x. So that would be 7 times 20, and of course that angle there would be 140 degrees. Okay, now it did not say to do that, but just be careful for directions like this, because whenever you have directions that tell you to find an actual measurement of an angle, you've got to go back and substitute your x value in. Again, directions just said find the value of x, but if it said find the measure of an angle, you'd substitute. All right, let's look at the next one. In this one here, we have an angle here. Again, there's no letters on this one, so we don't really know what they are, but we do know in this case that we have an entire big angle here, right? We have two little angles inside of an entire big angle here of 90 degrees, and we know that by our box. So we know they have an angle, the measure of one angle plus the measure of another angle equals 90. So we're going to add these two angles together. So one of our angles is 3x plus 4. The other one is 2x minus 4. So there's our two angles, and they add together to equal 90. So let's combine like terms. We have 3 and 2, that's 5x, and we have positive 4, negative 4. That's going to cancel out. So we're going to be left with 5x equals 90. Of course, divide by 5 on both sides, and your x value works out to be 18. And again, the directions just said find x. Okay, let's look at the next page. All right, now we're going to talk about congruent angles, okay? Congruent angles are going to be angles that have equal measures. If they have the exact same measure, here we have two angles that are both 48 degrees. So we can say that angle XVW is congruent to WVU, okay? Or we can say they're equal. Remember, the equal sign is when you know the measurements, okay? This is when you know the measurements. And notice something very important in this. When you know your measurements here, you're using the little m. You see the little m there? Those m's are important. Those m's are very, very important there. Pink highlighter here, let's highlight those. Right? Those m's are in front. You use that whenever you use the equal sign. In this one over here, you have angles that are congruent to. Whenever you use the congruent symbol there, you do not use the little m's. Okay, the little m's are not used. Remember, that is for when you don't know the exact measurements. You know they're equal. Okay, you know angles are equal, but you don't know the measurements of them. That's where you don't know the exact measurements. Okay? As opposed to when you use the equal sign, you know the measurements. We had that before when we talked about segments. It's the same concept here for angles. All right, let's talk about the angle bisector. The angle bisector is going to be a ray. It's always a ray. So whenever we name an angle bisector, it's a ray that divides an angle into two congruent angles. So this large angle right here, angle XVU, was bisected by this ray VW. So the question says, what is the angle bisector of XVU? Well, it's ray VW. And we know that because we know that those two measurements are equal in the picture. They told us that they were both 48 degrees, okay? You know it because the measure of angle XVW is equal to the measure of angle UVW. Again, these are actual measurements. You know that they are both 48, so you 100% know for sure that the measurements are equal, okay? Angles are both 48 degrees. Okay, that's an exact measurement. Okay, so you use equal sign. Okay, so we're using the equal sign with the little m's there because we know that the exact measurement is 48. All right, let's take that concept and apply it to these questions here. All right, so it says find the measure. Now, we have some different things going on here. First of all, what I like to do with these problems is I like to find as much as I possibly can. For example, I have a straight line right here. Straight line. This angle, we know if it's a straight line from here all the way to here is 180. That whole angle is 180. So if we take 180 degrees and we subtract 78, we are going to be left with what this measurement is right here because little angle plus little angle equals big angle, right? So these two angles add together equal 180. So if I take 180 minus 78, I'm going to find out that that measurement is 102. So that angle right there is 102, okay? Now, I can do the same thing again going this way, right? Here's another straight line. From here to here, 180 again. All right, now I know this is 180. I know this little angle inside here is 102. Right, all this in here, this little piece here is 102. So the question becomes, how much is the rest of it to make up the 180? How much is the rest? Well, again, this time we're going to do 180 minus 102, and what are we going to get? 78. It's not coincidental that they are both 78 degrees, guys. That's not coincidental. We're going to learn about something in the next section called vertical angles, and these are angles formed by an X. There's an X being formed right here. And these two angles are across from each other. Those two angles there will be congruent to each other here and here. They are both 78 degrees. Okay, we have one final measurement to calculate, and that is our little angle right in here. Now, we have an angle here, right, that's 180. Let's do it this way. This whole angle here, all this, another straight line right here. All that together, that's 3 angles that add to 180. So I have 3 angles that add to 180. I have the 51, I have the question mark that I had in there, I have the 78, and all of that will equal 180 degrees. So I need to calculate this, all right? So I have to add up these numbers here. So that gives me 129 plus our question mark equals 180. And when we subtract that 129, that missing angle works out to be 51. So this question mark angle now that we just found is 51 degrees. And look at that, they are the same measure. Now, because they're the same measure, remember, we know something right now. We know that we are going to have an angle bisector. This right here is cutting this big angle here in half. Those 2 angles are both 51. 51 plus 51 is 102. Okay, so that angle right there is 102. It got cut in half. These 2 are both 51. So we know we have an angle bisector now as well. Okay, we also know we have an angle bisector. So let's take a look at this one. Now we're going to answer the questions. If the measure of angle CFB, okay, we're finding that measure if AFC, okay, AFC is a straight angle. Well, we knew that was a straight angle. It asked us to find CFB. We already found that. That was 102. Okay, let's look at the next one. Find the measure of DEF. DEF. Again, we already found that. This right here made 180 degrees. Okay. Actually, I'm sorry. DFE we have to find. DFE. This one right here. Sorry, DFE. Well, we found that. We said that these were both 51. We did all the calculations here. We figured out that that's 51, but this says find it if these 2 are equal. Well, we know that had to be 51 in that case. If it's telling us that EFA and DFE are equal to each other, these 2 angles are equal, I'd like to put these little slash marks on there indicating that those 2 angles are equal to each other. They're both 51. The next one says find EFC. EFC. Okay, that is a big angle, EFC. E to F to C. That is actually all of this. All of this angle in here is going to be EFC. So in order to find that, we've got to do a little angle addition to find that. We have to take the 51 plus the 78, and we will come up with 129. Again, that's that big angle right in there, angle EFC. Okay, let me highlight that a little bit better so you can see that EFC. All of that is what they're talking about. So we had to use the angle addition postulate. And finally, on this last one here, it says find CFG. C to F to G. Now, we don't have a G here. It says find CFG if FG is an angle bisector of CFB. So we're going to have to cut an angle in half. All right, this can be a little tricky, but if you take a look, this angle right here is CFB. I'm going to cut it in half. That's my ray. F is the middle letter towards G. We're going to add a G to this picture. So what they now want us to find is the measure of CFG. They want us to find just this little half right in here, just half of it. Well, the question is, how much was all of it? How much was all of this angle CFB? Well, we had CFB. It said it right here in this one. CFB was 102. All of that was 102. Now, when you think about that, if you have an angle bisector, you are cutting the angle in half. You're cutting the angle in half. So my big angle is 102. If I am going to cut that in half, divide it by 2, I am going to get 51 degrees. So each of these little 2 angles in here would be 51 degrees, just like they were up here. Okay, let's continue. All right, this last concept is kind of a lot, but it's when you're using the angle addition postulate with problems that have angle bisectors in them. All right, now a couple things. First of all, remember that an angle bisector here makes 2 congruent angles, okay, or equal. Okay, so this is what an angle bisector does. It makes two angles either congruent or equal. Okay, and again, it doesn't matter. They're equal if you know the measurements. If you don't know the measurements, we just say that they're congruent. Okay, so that's what an angle bisector does. So if I have this picture right here, and I have angle AOC, and I know that this ray, OB, is a bisector. Let's say I know OB is a bisector there. Then I know that these two angles are equal to each other. Angle 1 is equal to measure of angle 1 is equal to the measure of angle 2. Now, what do we also know based off this picture? Not only do we know they're equal, we also know that we could add these two together and they would equal the whole entire large angle, right? You have a little one in here, right, plus a little one over here, and when you add them together, they make up the entire big angle. So the measure of angle 1 plus the measure of angle 2 equals the whole big angle. So these are the two things we know. We know if we have a bisector, it makes two equal angles. We also know that a little angle plus a little angle equals a big angle. Now, here's an important piece of information, okay? And I have this order here for a reason. Since angle 1 and 2 are equal to each other, they can be substituted for one another. So for example, right here, I have this. If angle 1 and 2 are equal, I could put an angle 1 in for an angle 2. They're equal to each other, right? So if this one's 40, this one's 40. I could put 40 in here. And likewise, I could do the same thing here. If I know angle 2 is 50, right? And I know angle 1 is also 50 because I know they're equal. So if they're equal, they would both be the same thing. I can substitute them for each other. Now that is going to be important. And what I mean is I can rewrite two new angle addition problems using the concept of the angle bisector. So I can put angle 1 in for angle 2 and say angle 1 plus angle 1 equals AOC. Or I could put angle 2 in for angle 1 and do measure of angle 2 plus measure of angle 2 equals AOC. So just keep that in mind. That is something that's going to be very useful depending on the problem. All right, now with these kind of questions, guys, you've got to draw a picture. You have got to draw yourself a picture. Right here it says QT bisects. So you draw your angle, okay? The first thing we want to do is draw PQR. That's my very first thing. I want to draw the big angle. Then I want to put that bisector in. QT bisects. It doesn't matter, right? You've got to make sure it's being bisected though. You want to make sure you're putting that T somewhere right in the middle here, okay? Because you've got to have that bisector QT, which means now because you did that, these two angles are equal to each other. So since QT bisects PQR, right, we know that PQT is equal to TQR. We now know that they're equal, all right? The next thing we got to do is we have to label the diagram. This says RQT. So this part down here is 10x minus 13. And PQT, this part right here, is 6x plus 1. All right, super important here because you've got these two pieces. Now, you know they're equal. Many people are going to want to jump in and say, oh, this is like an angle addition problem. I think I'm just going to say that the measure of angle PQT plus the measure of angle TQR is equal to the measure of angle PQR. Yes, that is true. Here's the problem. If I start taking these things and substituting them in here, right, 6x plus 1 plus 10x minus 13, what am I going to put over here? I will not be able to solve this, okay? So we don't want to use this for this problem. We got to do something different. Now we know they're equal. So since we know they're equal, right, we're just going to set them equal to each other. That's really important right there. Set them equal to each other. Very important there. All right, so that's all we're going to do. We know that the measure of angle PQT is equal to the measure of angle TQR. So we are going to say 6x plus 1 is equal to 10x minus 13, and we're going to do the algebra and solve. All right, let's move the 6x over. I always take the smaller number to the bigger number. So I'm left with 4x over here. I have a 13 here, so I'm going to add 13 to the other side. And I get 14 is equal to 4x. Now, don't be alarmed by that. It is going to be a decimal. You can get decimal answers. Simply now divide by 4 on both sides, and you end up with 3.5 equaling x. And I know a lot of you like to flip that around, so instead you could write x equals 3.5. It does not matter. But always go back. Yes, we just found x. But what did the question say to find? This is the key thing. It says find PQR. Did we find angle PQR? PQR. That's the whole big angle. Well, you know what we have to do? We now have to do some substitution. We have to put x in here. So we're going to do, in fact, we're going to use I'm going to use this now. I'm actually going to go back to this because I need to find the whole big angle. So I didn't want to use it before, but I can use it now for the angle addition postulate. You can do this different ways, but I'm just going to set it up in the angle addition postulate so that we have a place to plug things into. So PQR is equal to the measure of angle PQT plus the measure of angle TQR. And then what I would want to do is I'd want to substitute everything in. So PQR, we don't know. PQT, that's going to be 6 times 3.5 plus 1. Okay, that's this whole first part, 6x plus 1. 6 times 3.5 plus 1. Plus TQR. So that's 10 times 3.5 minus 13. That is going to give us our value of PQR. And we want to put all that into our calculator. And once we put all that stuff into the calculator, you should end up with 44. So the measure of angle PQR is going to equal 44. That is an important step. If you forget that step, your answer is wrong. Yes, you have half of it with 3.5, but you need to go back and substitute to find all of it. So actually now what you just found is that this whole entire angle is 44 degrees, okay? You can plug in right here, 6 times 3.5 plus 1, right? That's 22. And then you can plug in here 10 times 3.5 minus 13, also 22, which makes sense because 22 plus 22 is 44. And that is the measure of our entire big angle. These two pieces inside here add up everything together and we get 44 degrees for the entire angle degree value. There's a lot to that problem. All right, and one of the key things we need to remember is that a bisector makes 2 angles equal to each other. All right, let's look at the very last problem. Similar problem, but a little bit different. First thing you want to do is draw your diagram, right? BD bisects. So you've got to put that bisector inside there, okay? And you want to put it right in between to make those two equal. And it bisects that entire large angle, right? ABC is the angle that is getting cut in half. All right, so let's now label our given information in here. ABD is this one right here. That's 2x plus 4. And ABC is the whole thing. That is 8x minus 4. And we put it inside here. Don't put it out here. A lot of students make mistakes, start sticking that 8x minus 4 out here. No, put it here. This entire angle, all of this together, is 8x minus 4. So you want it inside there. Now, the angle addition postulate, right, would be a kind of an obvious one for this because you have all of it. But here's the thing. We don't know what this one is. We have no idea what this angle is. They didn't give us that one. They only gave us this one and the whole thing. But you know you have a bisector. You know you have a bisector right now. So you know that they're equal. Remember before I said they could be substituted for one another? So I could put 2x plus 4 in here also. They are equal. The only problem is a lot of students will fall into this trap because they'll say, oh, they're equal. Let me set them equal to each other. Well, try to do that and see what happens. If I move this 2x to the other side, oh, that cancels out. And if I subtract 4 on both sides, I got nothing left. Everything cancels out. 0 equals 0. That does nothing for me. So I don't want to do that. I don't want to set these two little angles equal to each other. Instead, I'm going to straight up use the angle addition postulate on this one because I have 1, 2, 3 pieces of information now. When I have 3 things, I can use this angle addition postulate. So 2x plus 4 plus another 2x plus 4 is equal to 8x minus 4. See, up here, I only had the 2 little ones. I only had 2 things. So when I had 2 things like that, I needed to set them equal to each other to be able to solve for x. Here I have now 1, 2, 3. So I need to use angle addition postulate to be able to set that up. All right, let's combine like terms. I have 4x plus 8, right? These would be 8, is equal to 8x minus 4. I'm going to subtract 4x on both sides. That leaves me with 4x minus 4 equals 8. Add 4 to both sides. And I know I'm doing this quickly. So pause your video if you need some time to do this. Okay, 8 plus 4 is 12. 12 equals 4x. Of course, now we're going to divide by 4 on both sides, and x works out to be 3. Now, the question becomes, did you answer the actual thing that they want you to find? Well, you found x, but it said find CBD. right? CBD is right here. CBD, that's this angle right here. So we need to go back now and find the measure of angle CBD, which we know is 2x plus 4 because that was a bisector and both of those are equal to each other. So now we're going to take 2 times our x, we're going to plug that in, 2 times 3 plus 4. And of course, that is 6 plus 4. That works out to be 10. So the measure of angle CBD there is equal to 10. I know that that's a lot. You may want to go back and rewatch the video, especially for these 2 questions on how they are done. All right? These are very difficult. The key thing I want to tell you is when you have a bisector, it makes 2 equal angles. Sometimes you set them equal to each other if you are only given these 2. But if you're given the entire big angle and you're given one of these, you know these are equal because it told you right here that it was a bisector. So if you know they're equal, you can label them the same thing in this problem and then add them together and set them equal to the entire large angle. Okay, good luck. It's a tricky section, so you might need to go back and rewatch.